Good morning to all. Welcome back to our course on the data structures. In this session, I am planning to discuss the quicksort algorithm. So, we will be discussing about the basic idea behind the quicksort, or we can also say that this is the algorithm for the quicksort. Idea or algorithm, and then we will explain or we will illustrate the quicksort algorithm on an unsorted list of elements. Let us go with the idea behind the quicksort algorithm. The first and foremost step for the quicksort algorithm is to find the pivot element or to select the pivot element. You will be having the list of unsorted elements which is inputted by the user, and from that list of unsorted elements you have to designate one element as the pivot element. In the previous session we have discussed the various strategies that are used to implement the pivot. We can make use of any of the strategy, but median of the three elements like the first, last and middle element will be somewhat a better choice. I do not guarantee that, I am not assuring you that that particular median of three elements gives you the best pivot element in all the scenarios. It may also give some it may also end up in some bad pivot. That means, it will give a pivot where one side is having very large set of elements and the other side will be having smaller set of elements. And after this first step where we are going to select an element as the pivot, the second step is you have to throw that pivot element to either end of the array. So, here we have given it as the rightmost element. So, you have to exchange the pivot with the rightmost element, but this is not all the in all the cases, right. You can also exchange the pivot or you can also swap that pivot element with the leftmost element also. So, either you can do it with the rightmost or you can do it with the leftmost, anything is okay. Once you exchange the pivot element with the rightmost element, now the actual algorithm comes into existence. The step 3 is very important. Of course, the step 1 and step 2 are also important, but here the algorithm, entire algorithm goes here itself. So, from the given list of unsorted elements excluding the pivot. So, you have thrown the pivot element to the rightmost, let us consider the rightmost only, forget about this. You have thrown it to the rightmost part and excluding this rightmost part from the remaining list of unsorted elements or from the remaining unsorted list of elements, you have to select two pointers. One is called as the left pointer and the other one is called as the right pointer. Let me take a generalized example x 1, x 2, x 3, x 4, x 5, x 6, x 7 and x 8. So, these are the list of elements that I was given and I select a pivot and I throw it to the rightmost part. So, this is a pivot element. From the remaining 7 elements from x 1 to x 7, I have to take two pointers. One is the left pointer which is pointing to the leftmost element like this. The second pointer which I am going to take is the right pointer, I am naming it as right. You can also give it as low and high also, nothing wrong in it. So, when you take these 2 pointers, the left and right, and you make the left pointer to point to the leftmost element and the right pointer to point to the right element, but not rightmost element, but not the pivot. It must be very clear, right. After this, the purpose of this left pointer is to keep track of the elements which are less than pivot, and the purpose of this right pointer is to keep track of elements which are greater than or higher than the pivot element. So, for this what you will do is, you will compare the element that is pointed by the left pointer, that is x 1, with the pivot. We know that left is always less. So, if x 1 is less than x 8, that is x 1 means the element that is pointed by left is less than the pivot, then nothing you have to do, you just have to increment the left pointer. Assume that x 1 is less than x 8, therefore, you have incremented the left pointer. So, my left is pointing to this location. This is just a generalized example I am explaining. Now, again you compare this x 2 value, that is the element that is pointed by left, which is x 2, with pivot. Now, let us take a scenario that x 2 is less than x 8 again. In this case, what you have to do? You have to just increment the left pointer, so that the pointer is pointing to the next element. This process you have to continue, that means the incrementation of the left pointer should be continued until you come across an element which is greater than the pivot. Remember, it is very simple logic, nothing to worry about it. Left means always less. So, if the element is less than pivot, leave it, go to the next element. If the element is that is pointed by the left is greater than pivot, you stop there. For example, let us assume that the third case where the left is pointing to x 3 is greater than x 8. Now, what you have to do? You have to stop the left pointer. So, by these 3 points, what we are going to understand is, you have to make the left pointer to point to an element that is greater than pivot. So, left should always point to an element less than pivot. If it is pointing to an element which is greater than pivot, then you have to stop the incrementation of the left pointer. That means, you are identifying the greatest element from the left pointer. Now, if you find such an element, you just stop it. Now, you go to the right pointer. The main purpose of the right pointer is to identify the lowest element or the element which is less than pivot. The same thing you have to do. So, you start comparing the element that is pointed by right and you compare it with the pivot element. The right pointer should point to highest element. If it is pointing to highest element, it is not violating the condition. Why? Because right pointer should point to lowest element. So, the right pointer, let us take this case, first one. Let us assume that x 7 is greater than x 8. This is what we want. So, nothing to do with x 7. So, what you have to do is, you have to move the right pointer towards its left hand side. Therefore, you are decrementing the right pointer. If you decrement the right pointer, right will be pointing to this location. What do you mean by pointers? Means nothing but their indices 0, 1, 2, 3, 4, 5, 6 and 7. So, initially you will make the left is 0 and the right as n minus 1, that is 7 minus 1, that is 6. So, if right is pointing to x 7 and if x 7 is greater than x 8, you have to decrement the right pointer like this. Now, let us take the same scenario x 6 it is pointing, x 6 greater than x 8. So, what you have to do? You have to decrement the right pointer. Right is pointing to highest element, nothing to do. You have to stop decrementing the right pointer whenever you find an element which is less than the pivot. So, in the third case, here you have decremented it from 6, it will come to 5. Assume that this is a case where x 5 is less than x 8, it is violating the condition. So, you have to stop decrementing. Now, at this position you can see that x 3 is greater than x 8 and x 5 is less than x 8. So, for this case you have to swap this pointer or this element with this element and this element with this element. Right. So, this is what happens here. So, what happens after this one is x 1, x 2, x 5 has been swapped, right. Here I get x 5, next x 4, next x 3, x 6, x 7 and x 8. After this, still my left point is pointing here and my right pointer is pointing here. Again you continue the process, and next this is also completed, step 3.1. So, when you find these two elements, you can see here, go through the list of elements both from left and right ends. From the left end, search the elements that are greater than the pivot. From the right end, you search for the elements smaller than the pivot. When you find such two elements, then exchange them and move on. And at one particular point of time, at step 4, what happens is the left and right pointers cross each other. They cross each other. When the pointers cross each other, then you have to exchange the pivot with the left pointer, that means the element which is pointed by the left. Remember, very important point, you have moved the pivot element towards its rightmost part at the second step, and when you are going to exchange the pivot or when you are going to make the pivot to sit in the correct position, you have to exchange the pivot with the element that is pointed by left pointer, very important thing. So, when you throw it to the rightmost end, you have to replace it with the left pointer value. But if it is the reverse case, that means you have thrown the element towards its leftmost part, or the pivot has been put in the leftmost part, and when you want to exchange the pivot with the value that is pointed by right. So, when you throw it to the left, you have to exchange it with right. When you throw it to the right, you have to exchange with left. This is very important. So, after this, the pivot will be positioned at the correct position, or the correct place has been occupied by the pivot. After this, you can observe clearly that all the elements towards the left hand side are less than the pivot and all the elements towards the right hand side are greater than the pivot. So, what you will do is, you will skip the pivot and you take the left elements or the left subarray and the right subarray. Again you apply the quick sort with the same procedure, selecting the pivot, throwing it to the rightmost part, select two pointers left and right which are pointing to the leftmost element and n minus 1th element in the subarray. You find the smallest and greatest elements from the right and left parts respectively, and when they find, you swap them, and at one point of time both these pointers cross each other. At this point, you have to exchange the pivot element with an element that is pointed by the left. You have to repeat this process for both the subarrays. Again you will get sub subarrays. You implement the quick sort on the sub subarrays. Like that you should proceed till you get the list of elements in the sorted order. So, the method you are going to implement here is the recursion. You are going to implement the recursion here, very important thing. So, this is the basic idea behind the quick sort, very simple thing. Let me have a quick recap of what this quick sort idea is. The first step is pick an element as and designate it as the pivot. Second step is throw that pivot element either to the leftmost part or the rightmost part. Third element is take two pointers left and right, The left should always point to left, the right should always point to higher element. Left should always point to less element and the right should always point to greater element. So, you keep on moving the left pointer and the right pointer such that you find a greater element from the left hand side and a lesser element that is pointed by the right pointer. In such situations, you swap those two values and you go on or you move on. When you move on at one particular situation, you will come across a situation where the left and right pointers cross each other. When this situation happens, you have to exchange the pivot element with the element pointed by the left pointer, or this is the case when you are throwing the element to the rightmost element, when you are throwing the pivot to the rightmost element. But when you throw the pivot to the leftmost element, when two pointers cross each other, you have to swap the pivot element with the element pointed by the rightmost pointer. This is very important. And you have to keep on moving this, you have to keep on implementing this quicksort algorithm recursively on both the subarrays and until you get the list of elements which is sorted in order. Now, let us see this with an example. Let me take a list of elements like this and let me explain it on the whiteboard. Give me 1 minute. So, here I have taken a list of elements as a list of unsorted elements as 38 and I have 82, I have 22, I have 48 and then 13, 69, 93, any random list you can take, nothing wrong in it, 14, 45, 58, 79 and 72. This is the list of elements that are given by the user and I want to trace the entire quicksort algorithm on this unsorted list of elements. First of all, you just need to have an idea. This is not a part of the algorithm. You should have an idea on how many elements are there. So, this is the array. I have stored all the unsorted elements in the array. Let me start my array index with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, a total number of elements is equal to 12. This is just for our idea, that is it. Nothing will do with this number of elements. So, what is step 1? We know that step 1 is identifying a element and designating it as pivot. What is the strategy we will take? We will take the median. Let us take the median of 3 elements. Median of the first, middle and last. So, what is the index of first element? It is 0. What is the index of middle? Last element is 11, right? How do you find the middle? It is 0 plus 11 by 2. It is 11 by 2, 5.5. Either you can take the floor value which is equal to 6, or you can take the seal, sorry, this is seal and this is floor. you can take the floor value which is equal to 5, or you can take the seal value which is 6, right. So, this is an even number of list. Listen carefully. Since you have an even number of list of elements, there is no exact middle element. You will get the middle element for these two values. So, this 5 and 6, these two are considered as the middle elements. And previously in the previous discussions I told you that you can select any of it. That means either you can go for the floor, that means either you can go for this 69th element, or you can go for the seal value of the middle element, that is seal of 5.5 is 6. So, you can go for this element also, this one or this one, anything is okay. If you go towards the left hand side, it is called as the left biased, and if you go towards the right hand side, it is called as right biased. So, let me go with the left biasing, left biased median means you have to take the floor value. So, I will take the element which is pointed by here, this one. So, this is taken as pivot. So, pivot is equal to 5, that is the element pointed at 5th location, that is 69. Now, we will go for step 2. Step 2 is you have to throw the pivot to rightmost end, or you can also say like swap pivot with rightmost element. So, for this what we will do is we have to swap this element with this element. So, 69 and 72 should be swapped. So, after swapping what I will get is, I will redraw the diagram again. The first one is 38, now I have 82, 22, 48, 13. Now, you can see here instead of 69, I will get it as 72. Right. Let me take another ink. This is 72, and then I have 93, 14, 45, 58, 79, and here I get 69. Again I will draw this array. So, this particular last element will be our pivot, right? Very good. So, we are done with the selection of pivot, which is the median of the first, middle and last element, and we are done with exchanging the pivot element with the rightmost element. Now, it is time to move to the third step. In the third step, you have to take 2 pointers. Let me give the indices also. For understanding purpose, I am writing these indices. Everything will work out with the indices only. So, you take 2 pointers left and right, or else you can also take it as low, high. It is the programmer's choice. Let me go with left and right. You take the left pointer and point it to the first index, that is, it is pointing to 38. That means, I just need to take the left value as the first index, that is 0, and I take, you should not consider this pivot, this is separated. this is separated. And now you take the right pointer and make it point to the n minus 1th element. I know that n is 12, right, number of elements n is equal to 12. So, if I make it as n minus 1, it is nothing but the highest index is 11, and if I make it to point to n minus 1, it will be pointing to 10. So, my right is pointing to this element 79. Now, it is time to search or move the left pointer and right pointer towards its right hand side and left hand side respectively, until unless you find the greatest element that is pointed by the left pointer and the lowest element that is pointed by the right pointer. Let us go with left. My left pointer is pointing to 38. Compare this with pivot element. So, what is pivot? It is 69. 38 compared with 69. Left is pointing to, that is A of left is less than pivot. This is what we want, right. So, in such case nothing to do, you have to increment the left pointer. So, 38 that left pointer is incremented, therefore, it will become 1 here. Initially it is 0, now it becomes 1. So, what happens here? Left is pointing to this position. 82 compared with 69. Now, it is violating this condition. So, A of left is greater than pivot. Now, you have to stop incrementing the left pointer. Very good. Now, you go to the right pointer. What is A of right now? A of right is 79. Compare it with 69. It is greater than pivot. This is what we want. So, nothing to do, you just decrement the right pointer, right minus minus. When I make the right minus minus, 10 will be decremented to 9. So, the right is pointing to this location. Now, again do the same thing. A of right compared with pivot, A of right is at this position, A of right is less than pivot. This is violating the thing, right. Then you have to stop incrementing the right pointer. When you have the left pointer pointing to the greatest element and the right pointer pointing to smallest element than pivot, you stop there and you exchange these two elements. So, this 58 and 82 should be swapped. So, when you swap these two elements, let me take a new page. Let me write these elements first. After swapping, it is 38, 82 should be swapped with 58. So, instead of 82, I get it as 58. Now, I have 22, again 48, 13, 72, 93, 14, 45. Here instead of 58, I get it as 82 and then 79 and finally, I have 69. Let me take the indices again and the last element this one, this is pivot, and where I have been left, the left is pointing to 1 and my right is pointing to 9. This is the position where it was stopped. Now, again continue with the same algorithm. Now, A of left, that is 58 is less than 69, therefore, increment the left pointer. Now, my left pointer is pointing to this location. Again do the same thing, A of 2, that is 22 compared with 69 less than, therefore, increment the left pointer, move on. My left is pointing to 3, that is 48, compare 48 with pivot 69, it is also less than, therefore, you increment the left pointer, it is pointing to this location. Now, 13 compared with 69, again it is less than, so increment. Now, here, now 72 compared with 69, here the condition is violated, that means A of left is greater than 69. Now, you have to stop it here. Go with the right pointer. At this point 82 compared with 69, since it is greater than, you decrement the right pointer, therefore, right pointer is pointing to 45. 45 compared with 69, it is less than 69, therefore, the condition has been violated. Now, you have to stop here. Now, you have to exchange the elements that is pointed by left and right pointers. This is exchanged with this one, that is 72 is exchanged with 45. Let me take the new list 38, sorry 58, 22, 48, 13, 72, sorry, instead of 72 I should have 45 and then 93, 14, instead of 45 I have 72, 82, 79 and 69. Let me take the indices also. This one is pivot. Now, previously I was stopped at this position when right is equal to 8 and left is equal to 5. Continue the process. Array of 5, that is 45 compared with 69 less than, so increment it, go to the next element. A of 6, that is 93 compared with 69, A of 6 is greater than 69, it is violating, so stop here. Now, go to the right pointer. 72 compared with 69, since it is greater than, decrement the value of right such that right is pointing to index 7. Now, A of 7, that is 14 compared with 69, it is less than, so stop here. Now, it is time to swap these two elements. Let me write them again, 38, 58, 22, this is 48, 13, 45, instead of 19 I will get 14 and 93 here, 72, 82, 79, 69. The last one is pivot. Now, I was left at the left pointer pointing to 6 and the right pointer pointing to 7. At this point, continue the process. So, A of right 93 greater than 6, sorry, you got the left side, right. A of 6, that is 14 less than 69, increment it. So, left becomes 7 and this is pointing to this location. Now, A of 7, that is 93 greater than 69. So, it is violating it, stop here. Go to right pointer. A of 7 93 greater than 69, you decrement this one and it is pointing to this 14. Compare 14 with 69, 14 is less than, therefore, we have to stop it here. Now, you can see that the left pointer is pointing to 7 and the right point is pointing to 6. Here, by looking at these 2 pointers, you can say that they have crossed each other. That means, the pointers have crossed each other. When the pointers has crossed each other, you have to go for step 4, which says that this is the right time to swap the pivot element with the left pointer. That means, whatever the element is pointing to the left, you have to swap it with that particular element. So, left is pointing to 7, right, that is 93 and 69. You swap these 2 elements. Now, let us redraw it 38, 58, 22, 48, 13, 45, 14 and instead of 98 I get it as 69. Now, 72, 82, 79 and 93. So, this is my pivot, right. Let me draw it with separate color. This is my pivot. See here, the pivot should be exchanged with the element pointed by the left pointer. Why? Because the pivot has been moved to the rightmost in the initial stage. But when you move the pivot to the leftmost position at this position, you have to swap the pivot with the element pointed by the right pointer. This you have to be very careful. And so, this is the first iteration. At this point, you can observe that 69 has occupied the correct place. That means, it has occupied its correct position, this one. And when you observe the left and right subarrays, all the elements towards the left, which are 38, 58, 22, 48, 13, 45, 14 are less than pivot, and all the elements towards the right hand side 72, 82, 79, 93 are greater than the pivot. They are not in the sorted order, but the list of elements towards the left hand side of the pivot are less than pivot and the elements towards the right hand side are greater than pivot. So, once the pivot has occupied the correct position, now you can see, just to have a clear idea, is this a good pivot or an average pivot or a worst pivot. A good pivot divides the given list of elements into 2 equal halves, but on the left hand side you have 7 elements and on the right hand side you have 4 elements. So, it is not dividing it into 2 equal halves. Therefore, this pivot selection is not a good is not the best case thing, and since they are almost equal 7 and 4, of course, they are not almost equal, but you can take it the selection of pivot as the average selection. The worst case means all the elements will be towards only one part, the other part will be 0, but this selection of pivot can be considered as an average pivot. So, you will get an average efficiency. Once you have this pivot, all the elements towards the left hand side are taken as left subarray and all the elements towards its right hand side are taken as right subarray. You should not change the order, this is very important. So, people will keep on changing the orders, but you should not change the order. Now, what happens after this? After placing the pivot in its cut position, you take the two sub arrays, that is 38, 58, 22, and then I have 48, then I have 13, then I have 45, and then 14, and this 69 is excluded. Why? Because it has already occupied its correct position. Now, on to the right I have 72, 82, 79 and 93. So, I have 7 elements on the left hand side like this, and I have 4 elements on the right sub array. I can take it as left sub array and the right sub array. Right sub array consists of 4 elements and left sub array consists of 7 elements. Right. Now, you do not change these indices, you are going to work on the same array, even though you are taking it as a sub array, you are going to consider it as the same array. So, 8, 9, 10, 11. Now, we apply quick sort on left sub array separately and quick sort on right sub array separately. Let me go with only one example of the implementing the quick sort on the left sub array and then quick sort on the right sub array. So, the first step, let me go with the left sub array first. Step 1 is selecting the pivot. We have taken the pivot as the median of first, middle and last. The first one is 0. Here the last element is, remember that this is a left sub array, therefore, you have to consider the 6 as the last index, and the average is 0 plus 6 by 2, that is 3. See here I have 7 elements, therefore, this is an odd numbered list of elements. So, I will get only one element. So, this element is considered as the pivot. Now, after selecting the pivot, you place that pivot or you swap this pivot with rightmost element of left sub array. You should not consider these things. This you should not disturb the previous pivot and you should not go for the right sub array. I am only explaining about the left sub array. So, the rightmost element of the left sub array is 14. So, you swap this pivot with this one. Now, I will get the list of elements as 38, 58, now 22, it will be 14, and then I have 13, 45 and 48. Zero, 1, 2, 3, 4, 5 and 6, and let me give a different color for the pivot. This is pivot. Now, the third step is take 2 pointers, left which is pointed to 0 and right which is pointed to n minus 1 for this sub array. So, here the last index is 6, therefore, it will become 5. So, it is left and right here. Now, we apply the same rule. Compare a left pointer value with the pivot, it is less than, therefore, increment. Now, left is pointing to this point, 58 compared with 45 greater than, stop it. Go for the right pointer, compare 45 with 48 less than. So, it is violating the condition, stop it. Now, you have to swap this 58 with 45. I am just redrawing it. (38), it becomes 45. Now 22, 14, 13, 58 and 48. This is pivot. So, my previous I have stopped at right is equal to 5 and left is pointing to 1. Now, go through the same process. 45 compared with 48 less than, increment the left pointer. So, it is pointing to this location. 22 compared with 48 less than, increment. 14 compared with 48 less than, increment. 13 compared with 48 less than, increment. 58 compared with 48, stop. Now, go for the right pointer. Right is equal to 5. 58 compared with 48 greater than, therefore, decrement the pointer. Right is pointing to 13. 13 compared with 48, it is less than, stop it. At this point, you can observe that left value is greater than right value. That means, the two pointers has crossed each other. At this point, you have to go for step 4. The step 4 is swap the pivot element with the element pointed by left pointer. So, my left pointer is pointing to 5th index, that is 58, this one. Swap 48 and 58, that is it. So, I get the list as 38, 45, 22, 14, 13, 48 and 58. So, this is my pivot, and this entire 4 elements is the left sub-array, and this 58 is right sub-array. So, you can see here the right sub-array consists of 1 element and left sub-array consists of 4 elements. So, this is also an average. So, whatever element pivot element you are choosing, the median of first, last and middle, it is going to end up with the average time complex or average case. So, unequal distribution of the two subarrays happens. Let me explain the concept, the same concept with the right subarray, and what you have to do is, you have to apply the quicksort on this left subarray and the right subarray also, and you go deep into this implementing of quicksort on all the subarrays and all the right subarrays. So, let us take this one here. I have these 4 elements 72, 82, 79 and 93. You should not change the indices. So, the index is 8, 9, 10 and 11. Step 1, first element, middle element and the last element. First element is 72, middle element is 8 plus 11 by 2, that is 19 by 2, that is 9.5. You cannot take the floor seal value. Why? Because in the previous discussions or in the previous implementation, I have taken the left biased thing. Therefore, I should take the floor value only. So, I should take the value as 9 only. You should not take 10. Why? Because the thing is left biased, right. So, you take the first as 8, the last as 11, the middle is 8 plus 11 by 2 and it is seal. So, the pivot element you have selected is 82. Now, step 2. Throw this pivot to the rightmost element, that means swap pivot with rightmost element. So, this and this has to be exchanged. Now, I have 72, 93, 82, 79 and then 82. So, it is 8, 9, 10 and 11. This last element is considered to be the pivot. Now, the same process, left, this is left, that is left is equal to 8 and right is equal to n minus 1, that is 10. Now, 72 compared with 82 less than, therefore, increment it, it is pointing to this location. 93 compared with 82, it is greater than, stop. Now, 79 compared with 82 less than, stop. Exchange these two values or swap these two values. So, I will get 72, 79, 93 and 82. This is pivot. Now, this is left and this is right. 79 compared with 82 less than, increment the left pointer. So, it is pointing to 10 here, left becomes 10, for it will go here, stop. And 93 compared with 82 greater than, stop. Right is 93 greater than 82, decrement the right pointer, right is equal to 9. Therefore, here the left and right pointers has crossed each other. When they cross each other, we have to swap the pivot with the element which is pointed by the left pointer. So, finally, I will get it as 72, 79, 82 and 93. See here, my left is pointing to index 10, which is nothing but 93. So, you have to swap these two elements. Now, at this position 82 has been occupying the correct position, and you can see that the elements towards the left hand side 72 and 79 are less than 82, and elements towards its right hand side 93 is greater than 82. It is dividing the list into unequal parts, therefore, this is also an average case. Like this, you have to go on implementing the quick sort for this left sub array, that is 79 and 79, and similarly you have to implement the quick sort on the single element of the right sub array, and this process should be continued until all the elements get sorted. So, this is how the quick sort is going to be implemented. I am not going to go through the entire process. I am stopping here. So, in this session we have gone through the basic idea of the quick sort algorithm, which is very easy. Pick a pivot element, exchange it with the rightmost or the leftmost element, take two pointers left and right, find the greater element pointed by left and smaller element pointed by right pointer. Whenever you find this situation, swap those two elements, and at one point the two pointers left and right cross each other. At this point, we have to swap the pivot element with the element pointed by the leftmost element, and you have to go on implementing this quick sort algorithm on the left and right subarrays until you get the sorted list of elements. And then we have explained it with one example. We have illustrated with one example of taking 12 elements. We have seen the complete example clearly, how we can implement the quick sort on the right subarray, how we have to take the pivot, how we have to exchange it with the rightmost element, and once the pivot has been placed in correct position, what happens to the left elements or the left subarray, and what happens to the right subarray. Everything we have explained it clearly. So, this is how we are going to implement the quick sort, and this is the end of our topic for today's session, that is the quick sort. Thank you one and all for joining the session.